Okay, so today's presentation is Java networking, a relatively simple concept. So we are going to spend maybe a few minutes going over basic concepts of networking. These basic concepts of networking really is not specific to Java. Java comes with some classes that you can use to write the client-server application using this low-level layer of communication protocol. So let's move on to go over some basic concepts of networking. IP address. IP address is an address that is assigned to each computer. It's just like a traditional mailing address. Each house has a mailing address. Now each computer has to have an IP address that identifies that particular computer on the network. Now there is IPv4 and I should say IPv6. IPv4 has been around for a long time. It's just a 4-byte field, and now we are running out of this IP address on the net. So now IPv6, this is a new the address scheme. It is 16 bytes, which should be enough for many computing devices for a long time. So basically, IP addresses is uniquely identify each computer or computing device. So this is an example of IP address, and then you also have what is called a host name. So host name is a symbolic name that has a matching IP address. Again, pretty straightforward and basic concept. Communication protocol is rules of engagement between two communicating parties. So every communicating, any communication protocol technology, whether that is RMI, remote method invocation, or CORBA or web services, they have their own set of rules of engagement. So those rules typically, for example, address the format of the data being sent over the internet or how and when it is sent. So here we are talking about in this presentation, we are talking about very simple low-level communication protocol. So one example of communication protocol in our daily life is, for example, when someone is calling, the response could be some greeting and then asking who that person wants to talk to, and then maybe there is some wait message. Yeah, so this is a typical way of conversation. In typical phone conversation can be captured as communication protocol. So basically, again, it is rules of engagement between two people on the phone. So some communication protocols, the also a little bit of high level, like HTTP, you can think of it as a communication protocol. FTP is also its own, has its own communication protocol. Telnet has its own communication protocol, so they have their own rules of engagement. So this is relatively straightforward. So I'm going to just move on. Port is a number. Basically the 2-byte number that identifies a particular service on a computer. Okay, so typically the type and address service must be known before information can be transferred or service can be accessed. So the address of the service is basically represented by a port. So if you're using a browser, sometimes you say localhost : then you specify the port number, and that means you are talking to that particular port for HTTP service. So port is 16-bit number that identifies each service offered by a particular computing device. So when you're trying to communicate, when you're trying to access a service on a computing device, you also have to provide a port number along with IP address. So On TCP/IP network, the standard ports are like a system ports. They are typically under 1024. So FTP service has a port 421, and HTTP service is on port 80 or 8080. And for your communication, the protocol, uh, you might you can actually have port number above 1024. Okay, so client-server paradigm, basically server provides a service and client trying to access the service. So that's basically how things work. So a server can be accessed by multiple clients. Okay. So in this case, we have 3 clients talking to a service on a server. Okay, so now a bit more technical content. Sockets. So what is a socket? The easiest way to understand socket is it represents an endpoint, communication endpoint. And so Java, all this low-level networking communication happens through sockets. Okay, so as long as you understand socket is representing an endpoint, and socket is actually being used underneath. Socket is being used to represent endpoint for Java and Java's communication protocol. So some of you might want to ask whether socket is the same thing as a port. Not necessarily. So a single port could have multiple sockets. So you can think of socket as a little bit higher abstraction of address than a port. Okay, so we are moving into APIs on Java. So we are talking about Java.NET package, and the classes that we are going to look into are these 4: ServerSocket, Socket, MulticastSocket, and DatagramPacket. Okay. There is a question from Virakum Suvinas on do we use sockets in this chat window? Very highly likely. Well, actually, yes or no. You know, the what we are actually using, it could be, the question is, the chatting that we are running on this GoToWebinar, it could be an application written on the top of socket. It could be also running on the top of HTTP. Okay, so it depends on how it is designed. So HTTP, you can think of it a bit higher level than the sockets. Okay, ServerSocket class. So ServerSocket waits for requests to come in over the network. It's basically the server side, the socket that is used to receive connection request. So when the connection comes in, then it creates another socket to receive the connection request. Okay, so when you create a server socket with the port number, so that is the port number that it is actually waiting for the connection request from the client. And now one important method of server socket class is accept. So basically, in this case, the server is waiting connection request from its client by invoking accept. So this blocks until there is a connection request from the client. And when there is a connection request from the client, then it will accept it, then it will create another socket. Okay, and this socket now represent an endpoint on the server side. So this is example code. So this is the server side. So this is echoing server application. It's basically receive the data from the client and just responds back. And it's using socket. So here we have a server socket, and then you have a socket variable. So basically, it created the server socket first on port number 1234. So this is the port number that representing this particular server. this service. Okay, so once you got the server socket, now by using the server socket, you can call accept. So this method is a blocking call. So this doesn't return until there is a connection request from the client. Now, as soon as there is a connection request from the client, then it will accept it, and then it will create a socket object and return it. So now you can consider socket as as I said before, this is the communication endpoint, which means you can send and receive data. So you can get the output stream from the socket, and you can get the input stream from the socket. So basically, we are receiving the data from input stream, and then we are writing it back. Okay, so that's basically what this code does. Okay, so we got the output stream, then we got the input stream, and then we have a print writer from the output stream, and then we have a buffered reader from the input stream. Okay, so once we got the printer writer and buffered reader, we are reading it, and then we are writing it to printer writer. Okay, yeah, we actually read a line, and then we write a line. Okay. So relatively straightforward. So let me just go over the logic one more time. You create a server socket. Okay. So again, you can think of server socket is like a, it's a person on the gate. It is the person that receive a request from someone else, and then will designate a desk or something like in a restaurant. So you can think of the socket is a designated, table on the server restaurant. Okay. Okay, so if there is another client trying to connect to this server, then it will create another socket for that particular client. So if there are two clients talking to a server, then there are two socket instances, right? And each socket instance will represent a different table on that server-side restaurant. Okay, moving forward, the socket. We have seen this, socket class in the sample application. Again, as I said before, socket is representing an endpoint for communication between two machines. Okay, so the endpoint also, because it's an endpoint that data could be coming in and going out, you can get the input stream and output stream object. Okay, so that's something that we just have seen. Okay. Okay, so this is a client code. So client code is going to create a socket by providing the the destination. So this is the destination. So server side IP address and the server side port number, and get the socket. Okay, and then it will have again input and output stream. Okay. And then it is actually doing the same thing. It's basically send something, and it's basically send something here. Okay, so yeah, okay, so let's actually go over this code. We got the input stream and output stream, and we got the printer writer from the output stream, and then we got the buffered reader from input stream, and then we got the buffered reader from a system IN, and so okay, so in this case we are basically waiting for the user to type something, and we will read it, then we will actually send it out to the server. Okay, and eventually we are going to close the socket. Socket is almost like a file ID, the file ID. So it's a resource that you have to actually close. It's like a database connection. Okay, so DatagramPacket class is representing datagram. Datagram is typically a data that is being transported over connectionless way, meaning the delivery of packet is not guaranteed. So this is representing UDP, the communication protocol. I mean, this data is actually being transported over a UDP communication protocol. So it's basically representing data format. Okay, so you can get the data. Okay, so MulticastSocket class. So MulticastSocket class is UDP datagram socket with additional capabilities for joining groups. So, if you have a need to send a message to a group of endpoints, then that's the time that you can create a multicast socket. Okay. Now, the multicast sockets IP address of multicast is actually within this range. Okay. Okay, so because multicast socket representing a group of the endpoints, that is what is called the join group, and that is leave group. So when you call join group, you're basically joining that group. When you leave the group, you're leaving that particular group. So once you join, whatever message that is sent to that multicast address will be received. Okay, and you can also send a message as well. So once you send a message, that message will be sent to everyone in that particular group. So sending a message to a group and should be a member of multicast group by calling join group method. And then you can also send a message and everyone receives it. And if you do not want to be part of that group, then you can again call the leave group. Okay, and it's actually using DatagramPacket, the object, to send data. So this is the data format it's actually using. Okay, so here we create, this is a code. So here, let's say this is the, let's say chat server. So suppose if you're building chatting application, yeah, so I think one of the questions that was asked earlier, this could be actually a chatting application that could be written using the multicast socket class. So the multicast socket, so each chatter is both the sender and receiver, right? So here we are building a receiver application. So we create the multicast socket object, and so this is the IP address, okay, in the form of inet address object, and then you join the group. So you're joining this multicast group, okay. And then it's going to receive the data, receive the data in the form of datagram packet. Okay, and as soon as it receives it, it will just print things out to the standard output device. Okay, so that is the receiver part of it, and this is the sender part of it. So again, it becomes a member of this group. Okay, then it will just send it. It create the datagram packet object, and then it will call the send method, passing the data object. So pretty straightforward. Okay, so the question from Paul, why is this in a loop? So you are talking about this guy, right? Yeah, so it doesn't have to be in a loop. So in this case, this application is designed in a way that it is actually receiving data, continuously. That's all. Okay, so if you do not make it as a loop, then it's gonna just receive it once. Okay. Okay, so let's take a look at the hands-on lab. So the hands-on lab is we are going to exercise unicast, server and client, and then exercise 2 is multicast receiver and sender. Okay. All right, so let's run the application. So network server, so this is network server code is something that we have seen in the presentation. So basically we created a ServerSocket, right? And so this is a person, at the gate of a restaurant, and and then it's going to call accept. Okay, so this is a blocking code, receiving a connection request from the client, and as soon as there is a connection request from the client, it will create a socket and return it, and then this is basically representing endpoint for communication. So you could have input stream and output stream. Okay, so the in this code is basically once we got the socket, then we create input stream, output stream, okay, and then you are going to wait a message from the client, okay. So I already run this application, so I just did basically run. So what we have is ServerSocket is created and then waiting for the connection request. Okay, so we are waiting here. Okay, right? So now we are going to run the client code. Client code is going to send the connection request, and then this guy will return a socket object after accepting it. Okay, so let's take a look at the client code. Okay, so client code basically create a new socket, basically specifying the server IP address and the port number. In this case, 1234. And so this code, this new socket will be returned. I mean, it will return the client socket object after server accept it. After server accept the connection request. And once the we got the socket object, then again we have client and the input stream and output stream, and basically the input stream data is something that you're going to type. Okay, so let's run the client. Let's run it. Okay, so client socket is created. Okay, and so if you actually see here, you can see connection request has been accepted from the client. In this case, we are using the same machine, so the IP address should be the same, but the port number of the client should be different. Okay. All right. So now client is going to type something. So I'm going to type my name here and enter. Okay. So now basically output stream of the client socket send the data. So that should be received by the server. So here. So the server received and it displayed the message that it just received. Message received from the client, and this is something that I sent from as a client, right? And then it's actually waiting for another connection request, and looks like it actually received the second connection request. Okay. Let's see. Now let's actually say B. Okay, so it sent the another request. So we actually have another server-side socket object is created and message received, and so that's how things are working in this code. Okay, so let's take a look at the multicast send and receiver. Okay, so this is the same code we have seen in the presentation. So basically, you create a multicast socket object, and then you're going to join the group. Okay, and then we are just waiting for the data coming in. Okay. So this is functioning as just a receiver. It's not playing the role of the sender, but it could. Okay. So let's run the chatting server. So now it joined the group and then it's actually waiting for some data, okay, being sent to this group. Okay. So now we're gonna run the client multicast sender. So multicast sender is again it joined the group, and here is basically sending the things that you're going to type. Okay. All right. So let's run the client multicast sender. So I'm gonna type Boston Red Sox. This. Okay, so now it actually sent a message to the group and then it just closes itself. So if I see that server, the receiver, it received the message that I just sent to the group. Now, multicast, as I said before, is a grouping, right? So here I can create another instance of the server. So I'm going to just create the another application representing server 2. Okay, so I'm going to, yeah, I already created server 2, so that's the reason it says. I'm going to say server 3. Oh, okay. Yeah, so 2 is fine. Yeah, it's just wanting, oh, okay, yeah, I guess I already have server 2. Copy multicast 2. Okay, 4. Oh, sorry. So, all right, so I practiced couple, so 3 and 2 and 2 already. So I create the multicast server 4 application. So I'm going to run this application again. So this guy is playing a role of a groupie. So we have 2 members in the groupie, multicast server and multicast server 4. So I'm going to run multicast 4. All right, so we have 1 and 2 multicast receiver. Now we are going to run the client. So this is playing the role of the sender. So when I run, okay, so now I'm going to send a message. Boston Bruins win. Okay, so I'm sending this message, and now I should see multicast server 1 receive the message, and multicast server and multicast receiver number 2 also should see the message. Okay, so you can see in multicast environment, multiple receivers should be able to receive a message that is sent to that a group. Okay, all right, so that should be the end of the presentation. So let me just